Here we have Peter Lambrecht. He's the Vice President, Key Accounts EMEA at Vertiv, and he's going to talk about the top 5 data center trends 2019. And one of them is that edge will lead change, isn't it?
Absolutely.
Peter, take it away.
Good afternoon. Is there a clicker or is somebody clicking for me? Or?
One here.
Sorry for Timo's enthusiasm.
Okay, no problem. Thank you. I'm not very technical, so I'll try to figure this out. I'm going to talk to you a little bit about the data center trends. And I'm not going to bother you with sine waves, what you normally and typically would expect from a company like Vertiv. I'm not going to do that. I'm not going to explain you how the grid works, so you're probably very happy with that. I would like to talk to you about what is really concerning us as an industry. What do we see as an industry that is potentially a challenge for us, and how we're going to overcome that. The first one I bring up is workforce. If I look in this room, I see a lot of gray hair, or people that used to have gray hair. I think that in the industry, we, over the last 5, 10, 15 years, we missed out on at least 2 generations of electrical and mechanical engineers. 10 years ago, if somebody would say, I'm going to go to university, I'm going to study electrical engineering, they would have said, oh my God. It was like a dirty word saying, I'm going to be an engineer, and especially a mechanical or an electrical one. And here we are, in this room, in the whole industry, we are screaming for engineers. Every single day, I have customers asking me, Peter, don't you know a good engineer? I need a mechanical one, or I need a specialized project manager that knows what he's talking about. Every single day. You must see how difficult it is to recruit people into your own organizations. And I'm not only talking about design engineers. Just imagine you're an electrical engineer in Dublin, and you want to come to work for us or for one of our competitors. You have the choice, because it's extremely difficult for us to recruit today new talent, new people that want to come into this industry, or you pay them an absolute fortune. So there is a shortage of talent. There is a shortage of engineers that understand this industry and that know where we're going. So we missed out, that's my statement, on 2 generations of engineers. We have to make very clear to the young people, to your children, to your grandchildren, that engineering is not a bad thing, and that this is the future, and that we need that for our future in the data center industry. But as we will not be able to onboard these people fast enough to follow the growth of the industry, we will have to change the way we do things. We will have to get more intelligent on how we do things, how we operate things, how we design things. So in the data center industry, very soon, we will see augmented reality. We will see artificial intelligence coming up. We need a lot more automation coming in. Otherwise, we will not be able to follow the demand of the market out there in the industry, simply because we don't have the people to do it. And that leads me to the second topic I want to talk about. I often say engineers, and this is a blunt statement, engineers have the memory of a goldfish. They swim around the pond and they've forgotten everything they've done before, which is good for a goldfish, for an engineer maybe a little bit less. So engineers typically try to re-engineer every time again what they think is now the best possible solution for the problem that was put in front of them. And I see a number of people nodding here. We have to get our industry into data center 2.0. We have to start industrializing this whole sector. It cannot be that we have to redesign an entire power stream every time after time after time again. A 1 megawatt block is a 1 megawatt block, right? If I read specs of certain customers, it's a 120-page document to describe how a UPS would work. We know that. That's our business. So probably we can use those resources differently. The industry has changed. We used to have customers that were asking us, okay, can we build a data center in 24 months? Those times are gone. We have customers that no longer talk in years or in months. We have customers that talk about, I want from shell to space ready for customer in 60 days. That changes the game completely. This means that you cannot re-engineer everything time after time again. You have to work with standard building blocks. Repeatability gives you more reliability. And guess what? It makes it a lot easier to maintain because it's the same. If you have 10 boxes with 10 settings, you can do the math how much that gives as possible combinations. And you want the human beings to operate that, it's not going to work. It's not scalable. And now we go to the edge. If we do not normalize, if we do not standardize what we're doing and our designs and our building blocks that we use within those designs, this will never work. So I really urge you guys to look at that and see what we're going to do with that. And I know that Paul, who comes after me, will talk about that as well. How can we really industrialize, normalize our environment? Because that's what's important. I talked about it, simplifying the edge. Most of these sites, and we talk about hundreds, potentially thousands of sites across EMEA, not to talk about across the world, if they're not standardized, if they're not automated, it won't work. Because these will be dark sites. Nobody will be there. So we have to do things differently. We, as a constructor, we will have to change the way that we want you to maintain equipment. We went from preventive maintenance. You have your technician that shows up 2, 3, 4 times a year to do the maintenance on the box. We went to predictive maintenance, because with big data and analytics, we can say and we can predict when a certain component will fail. Now we have to go a step further. We have to start thinking, how can we do self-healing of the box when something is about to go wrong? That's a completely different dimension. Because we will not have enough people to run around like madmen around these hundreds and thousands of sites. This is not going to work. So we, as a community, we, as manufacturers, we have to change the way we do things. Otherwise, not going to work. Another element, what we see, is that we have more and more high-power processors that require different elements, different technologies to cool and to maintain a certain environmental environment. This is a fact. So a number of people, a number of constructors, they started to experiment with liquid cooling, with immersed cooling, with extreme water, free cooling. So there are a number of technologies that we as industry are working on to see how we will be able to fulfill and to respond to the demand of the market that will be there tomorrow. Because what we do today might be either too complex or it will not fulfill what we want it to do. And the edge definitely will drive us to that. It has to be as simple as possible, as simple and automated as possible. And therefore, we have to look at different cooling solutions as well for these high demand processors. The last one I'm going to talk about, and as I promised, not on sine waves, UPSs. We're not selling anymore on efficiency. We're all there, all the constructors, we're all there, we're all 99 point God knows what efficient. It is how we will deal with the box in the future. How much intelligence can we bring into the box so that it is not only a black box standing in a black room, but we can actually do something with it. And my colleague from ABB, he was talking about how can we, all these micro-potential power suppliers that we have out there, how can we connect them to the grid and make sure that actually the millions or the hundreds of thousands of megawatts of power that we have stored in all our data centers, with the new battery technologies, we can turn a cost of an asset that is sitting there for 95% or more of its time doing absolutely nothing. How can we transform that into a revenue-generating asset for you? And that is the challenge what we have. We have done a number of projects, also in the UK. The UK is one of the most affected countries from that, because what you see, as you introduce more and more renewable energy into the grid, the more unstable your grid gets. So with UPSs and feeding back energy into the grid, we can actually help the operators to stabilize the grid. Because we sell them clean, we sell them clean power. We have 100% clean power sitting there in thousands and millions of batteries, and we don't do anything with it. So that's an opportunity for us. An opportunity, but you have to do it in an intelligent way. We're not going to jeopardize the operations of the data center, first of all. Yeah? But that's a huge opportunity. To round up, my biggest concern is people. You probably understood that. We have to bring in a lot more automation. Paul will talk about that. Automation is absolutely key. Simplify the environment. Don't be the goldfish engineer. Yeah? So with that, if there are any questions, I'm here for you.
Thank you very much, Peter Lambers. No questions? Well, I actually have one for you. You said there were no electrical engineers in the room. Correction, I'm one.
Okay. You want a job tomorrow?
No, well, the reason I stopped doing it is because it's so boring. So how can you make it more exciting? Well, the least you can do is tell this story at schools.
Absolutely.
I think you will recruit a lot of electrical engineers.
Well, there are two ways of tackling this. If you sit on a plane and you sit next to a nice girl and she asks you what you're doing, you can say, I sell UPSs, yeah.
Yes.
We try to correct sine waves and do things like that. And that's probably the boring part.
Yeah, that will really get it.
Or you can say, we work with customers like Amazon, like Facebook, like all these great names, yeah. And we help them to keep their infrastructure up. Yeah, and we are actually supporting the backbone of the whole internet. And whatever you do on your mobile phone actually has somewhere a connection into a data center. And all of a sudden, they say, oh yeah? Sounds a little bit more interesting than correcting sine waves.
Oh, pretty cool.
So that's, if you are ever interested, just let me know.
Advice for today, data centers are a bait magnet. Thank you very much.
Thank
Peter
you.
Lambert. And as he said, Paul Ike will elaborate on that. He will be talking about a disruptive change, automating and standardizing data centers. He's the Senior Vice President, Sales and Marketing, and he's already here. And he works at Unica Data Centers. Paul, please take it away.
So, there's a big light there. I've got gray hair. So, Peter, what should I do? Good afternoon. My name is Paul Ike. I'm running, together with Mark and Jeroen, Unica Data Centers in Amsterdam. Apologize for my voice. We are building data centers from 1999. So we have more than 20 years of experience in data center. And what I try to do today is try to explain a little bit, and I have to think, push buttons, what our thoughts are, how we look at the market from 1999 till now. And believe me, I'm running in the IT from 1979, so I'm 40 years in the profession, and it is unbelievable. Still, every data center we build, every IT environment I've built is not standard. Maybe you see that, but if I go to SAP, if I go to any enterprise system, every enterprise system have their goodies, baddies, whatever they do, but everybody has their own system. And I think when we look at as a general contractor, we build the data centers. We're not operating them unless the customer asks us. If we design them, and we together with Martien from Royal Haskoning, we are designing and building data centers. But how we look at it, the first thing we see is that the data is generated by the customer. The customer is you, me, everybody around it. And I didn't put IoT in there yet, but I think everybody understands that if I put the IoT there also, that we have an humongous amount of data coming into this wheel of fortune, I'm always saying. This is in 2018, the number of production you have on data. Now, how we look at the market is very simple. We look at the for us, simple. Hyperscales, co-locators, enterprises, telcos, and I think we have a fourth one, it's called the edge. And if you see, hyperscales are at the foundation of the tree at this moment. They're generating, together with the customers, so much data, they need hyperscales. And I don't know, I hope there is no definition, I think, from an hyperscale, but I think it is an open IT infrastructure, which is for every player in the field different. If you look at the design of a Google or design of a Microsoft, it's completely different. So going back to the first question about standardization, so if standardization is starting here somewhere, I think everybody has his own standard. There's a company from Redmond and a company from Redwood who's saying, I am the standard in data center industry. Uptime Institute is trying to sell you tier 1, 2, 3, and 4, and I think it's one of the foundations for a lot of people to design a data center. Green Grid is doing with the OSDA environment, the open standards for data center availability. So they are creating, let me say, rules for engagement for all those people. Now if I look and if I standardize, which is almost impossible, the base of the tree, we go up to the tree and we have the enterprise and the colos. If I want to standardize a single line diagram of Equinix and, for instance, interaction and that sort of stuff, so where is the unique selling point for those guys then? And I'm a general contractor, I'm looking at that. And I can always say, oh, you can do it always better. Or we do value engineering, we can create a better environment. But in the end, for the co-locators, it's the business model to sell their square meters, power and cooling at the most finest way they can, to the satisfaction of the customer. Look at the enterprise industry, they have to have a data center that makes the difference. If ING has a very good bank application, they can make the difference in clicking and making sure that you're in the fastest way possible from left to right. Let me say the telcos are the juice. They are making sure that all the data is going from left to right. The juice, which is provided by the customer, is going to the trees, and the telcos are putting it all in the branches. Now this is a very unique tree because if you look at the edge, it's coming up and it's going down. So everybody understands that the humongous amount of data which is created here, together with that wheel, we need to get organized. It's enormous. And I think in a couple of slides further on, I'm going to tell you that disruptive technology is now changing the world as we speak. And I think, talk about it 5 minutes later. So if I look at the data centers as digital plants, I think we have energy plants, we have digital plants. Data design factors are, for every customer, different. I think there are companies that say the ease of maintenance is for me very important. And the other one says, no, 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 the extended product life cycle is for me very important. So there is a huge differences in acknowledging or seeing how the market and how the data center design is set up. I think if you look at the footprint reduction, for one industry like the telcos, that's not an issue. It is the issue of ease of maintenance. So you see constantly different platforms rising. So from the tree, annual spend, refresh frequencies. In some hyperscales, very, very important because they have to have the newest technology first of all. So their agility, time of replacement is enormous. This one for me was a little bit shocking because when in 2004 Uptime Institute tried to get with the industry a power user effectiveness as a formula, and everybody I think here is saying we are not agreeing it. But it is the same as we have only one standard at this moment in the industry. This is a 19-inch rack. So on this one here, the power user effectiveness, now about 10 to about 35% is still above 2. Now I had a short discussion with Marcel from Rittal. You know, it's debatable, but still, if you look at the right side, the POE and awareness, but also the factuals are enormous. Is that lowering by standardization? I think every data center is engineered to order. That means that the customers have to go, let me say, to Royal Haskoning or Arup, then goes to me, we design it, then we're going to build it, we're going to set it. There is no Lego system, there is no building blocks. They're all building blocks, but in fact, every customer has their own building blocks. So if we can, in the industry, can come from an engineer to order to a configure to order environment, we can play the Lego blocks. You can make the difference in the design because I think if your kids are playing with Lego, you're very, very proud to say, hey, I made my car. But I think that's a way to go forward. Legolize the whole thing. And funny enough, and everybody knows that, within a data center, there are some predominantly features like cooling, which is giving you a lot of headaches. And that are changing the rules again and again. And there are a lot of new stuff coming on the market, but believe me, we are now at generation 9 or 10 of data centers. So let me start in 1999, we have the first generation, 850 watts the square meters, maybe less. And now we are sitting between 5 and 6, 7 kilowatts per square meter. So that's an enormous rise. But this is also a headache. What you see suddenly coming in is that there are a lot of stuff that are automated. A lot of systems are getting intelligent by the minute. The problem is we need to get it all together. So systems like processes are a must to get this organized. But there is no single system in the market, I don't know them, maybe you can tell me, which is helping you completely run a data center with a decision-making system in there. So monitor systems we can all make, but a decision-making system. Hey, your set point is going up, go left, go right, put it out and in. Completely automated. I think in the future, and I think Peter also said it before, artificial intelligence is going to help us with that. But I'm 40 years in the business, and I want to see young guys working on this issue, because they have the solution. If you see my son working on a computer, totally different. Oh, sorry. Disruptive. 5 days ago, IBM introduced the quantum computer. I don't know what you're thinking, but I'm thinking, holy crap. So there's your standardization, there's your CTO, there's your ETO. Anybody have an idea? I know there's some IBM guys here. You know what this thing is doing? There's a picture on the right. I can't zoom in and out, but this picture is 24.9 billion pixels. One picture. Made by a quantum computer. Now, I think you can do the arithmetics and cameras and that sort of stuff. these guys are going to generate an humongous amount of data. They're going to be processed by those guys. So this is actually the new machine of IBM. I'm trying to figure out how you're going to mention it, how you're going to do it, but it's a new standard. It's a new way of computing. It's going to be a new way of setting your data center up, new infrastructure. I don't know. But everybody was telling it about, 5, 6 years ago. The quantum computer is coming there. It is. You make one picture, you see 24.9 billion pixels. That means that everybody can make a picture of that picture. Funny. You see the new film of Lion King? The trailer? You see the photographic stuff on there? It's unbelievable. And that's generating, again, the enormous amount of data through that wheel, but also by quantum computers, by all sorts of computers. Now, my statement is that I like to automate and standardize an environment. I like to make it CTO, because as a general contractor, for me, it's a very easy thing. If I take the building blocks, I can build as much as can. So I've always worked, but it isn't. An average data center, design, build, operate, with everything in there, if you do it very quickly, Marcel, 24 months? Okay, but inclusive with all the councils and the city councils, the stuff in there is enormous. So what I'm saying here, disruptive, means that if this first one, and it's going to be generation 1, 2, 3, 4, 5, what happens in generation 5 in the whole data center industry? I tried to figure it out, but I couldn't in the last 2 weeks, so I need some experts. But I think also that. What I see, the trend in general, that customers are building modular. They want to build modular. They build quick, try to 6 with 8 months. They're developing situations in which you are, standardized on the customer. So first the shell, and then you see what the core is in that one, the MAP, what we say in our language. So what we try to do is to think with the customer, how can you repeat a data center without too much engineering after that? First of all, what Peter says, engineers are very scarce, also with us. We have to do a lot of that. But if we see that FlexiC is very simple, we engineer it, and we can do that multiple times. And we can play it as a Lego system. Now, it's not so beautiful as red and blue and yellowish as Lego, but it is the same principle. Principle, help the customer think in such a way. It's difficult, because everybody wants to have quick. They want special sizes. I know people say, no, I want a 4 megawatt. Now, a 6 megawatt for me is much better. The other one says, no, do 12. 10 years ago, we were talking about 1 megawatt data centers. So you see it's going more and more and more into the megawatts. Hyperscales, edge, micro data centers, it's all here. So from a perspective as Unica, as a general contractor, I have to listen to all your customers, and I have to all the customers here. And I have to interpret that in the design, in the build out, operate and maintain in a situation. So sometimes we have a lot of ears. So thank you for your attention. If you have any questions, please address.